Autoregressive Conditional Heteroskedasticity models, or the ARC models. Now, what do we mean by these ARC models? So friends, we have already learned what is heteroskedasticity, right? So, in an autoregressive model, what is conditional heteroskedasticity? Let's first understand that. So to understand this, let's take an example of an ARP model. So the order will be P and the model will be autoregressive, right? So this is given by nothing but xt is equal to b0 plus b1 xt minus 1 plus b2 xt minus 2 till xt minus p, right? Plus some error term, let's say epsilon t. Now, what is the criterion for conditional heteroskedasticity in this kind of a model? So this has been defined by Nobel laureate economist Mr. Robert Engel. Mr. Robert Engel has spoken about a way to find out whether a model is ARC1 or not. Now, what do we mean by ARC1? Basically, whether epsilon t is dependent on epsilon t minus 1 or not. This is what defines whether the model is ARC1. That is, whether there is conditional heteroskedasticity of order 1 or not. So if it is dependent, then there is conditional heteroskedasticity of order 1. If it is not dependent, there is no such heteroskedasticity, right? So let's say we are trying to verify it. Epsilon t, let's say, has a normal distribution. It has a mean of 0. Now, to verify whether epsilon t is dependent on epsilon t minus 1 or not, we define the variance of this normal distributions as a0 plus a1 multiplied by epsilon t minus 1. Then we check for this a1 value, right? If a1 is equal to 0 or is not significantly different from 0, then we can say epsilon t is not dependent on epsilon t minus 1, or that there is no conditional heteroskedasticity or ARC1 problem, friends. Let's say there is another scenario where a1 is greater than 0. In that case, what will happen, friends? In that case, epsilon t will always be greater than et minus 1. So et will keep on growing depending on the previous value in this kind of a scenario. So here we can say there is conditional heteroskedasticity, and the model is a ARC1 model. Right, friends? So this is a problematic model. Why? Because there are certain disadvantages of it. Like the standard error of this kind of a model is not reliable. That means we'll have to use generalized least squares to correct for this conditional heteroskedasticity. The second problem, variance becomes predictable. So for these two problems, ARC1 model becomes an unreliable model. Now, how do we test for ARC1 model? There is a method of testing it which is very simple, friends. We just regress the square of epsilon t with respect to epsilon t minus 1. Epsilon t square is equal to, let's say, alpha 0 plus alpha 1 multiplied by epsilon t minus 1 square plus some error, let's say, which is represented by lambda. Now we check for the significance of alpha 1. If alpha 1 is found to be significantly different from 0, then we say there is conditional heteroskedasticity. And if it is not significantly different from 0, then that means there is no conditional heteroskedasticity, and we are good to go. So friends, this is what we have to say about ARC1 model. Now there are certain generalized versions of ARC models. For example, ARC-P model and GARC model, or generalized autoregressive conditional heteroskedasticity model. So these two models have the similar kind of problems that an ARMA model has. What are those problems, friends? We have recently visited them. They are basically instability of the parameters, And number 2, forecasting is not that good or it is unreliable. So this is all about ARC models and ARMA models, friends. Now we will try to move on to the next topic, which is multiple time series regressed on one another.